Remember that when you find surface area, technically it's infinitesimally thin, super, super thin. So suppose we want to put a coating on that has a certain thickness. This is how we can make an application of surface area. So we have the curved surface of a funnel is generated by revolving the graph of y equals x cubed plus 1 over 12x on the interval from 1 to 2, which is exactly what I have graphed here. So from 1 to 2, you can see, right, this is A and B, right, for our integral, right? So there's A, there's B, no problem, right? So A equals 1, B equals 2, there we go. But we're actually going to go around the x-axis this time, which is really nice for us because that makes it easier. We don't have to solve for a function of y or anything. All right, so we're going to rotate around the x-axis. And so we're going to be building this funnel. And then we want to paint it to with a layer of paint 0.05 centimeters thick. All right, so hold that thought. We've got some things to think about here. All right, let's start with, and notice, by the way, we're finding volume, not surface area. So what we're going to do is we're going to find the surface area and then we're going to multiply. We'll do that later. That'll be the last thing we do. All right, so let's start with finding the surface area, shall we? Now, surface area is equal to the integral 2 pi integral from a to b f of x times the square root of 1 plus f prime of x squared. Oop, there we go. There. Dx. Forgot about my squared there for a second. Okay, so let's think here. I need to find f of x and I need f prime of x. But f of x was given to us. F of x is right here. Right? Hello, f of x. No problem there. So if f of x is that, then what's f prime of x? So let's go over here to the side and find that. So let me just do some calculus work here. F of x is equal to x cubed plus 1/12 x to the negative 1, right? Because I had x in the denominator. So then the derivative of that would be 3x squared minus 1 over 12 x to the negative 2, which would be 3x squared minus 1 over 12 x squared, like that. All right, so let's go substitute those pieces in, as well as a and b, which we already know. So the surface area is equal to 2 pi integral from 1 to 2. F of x, which we know is x cubed plus 1 over 12x. Make sure you put that x in the denominator. Square root 1 plus, and then I want f prime of x squared. So that would be 3x squared minus 1 over 12x squared, all quantity squared, dx. All right. I'm going to use a little bit of algebra here. This, I want to figure what that is. I can FOIL this on the right and then add 1 and combine like terms. So I'm actually going to go figure out that value in algebra. So let me go do it. So algebra work. I think I'll do it with this color. Okay, so I have 1 plus, and then it was 3x squared minus 1/12 x multiplied by itself. So 3x squared minus 1 over 12x squared times another 3x squared minus 1 over 12x squared. That'd be 1 plus 9x to the 4th. Let's see, minus 3/12, because the x squared are going to cancel when you do that. So minus 3/12 minus another 3/12. So minus 3/12, which I know is a 4th, but bear with me here. I'm trying to do one thing at a time. So if you want to see, it's x squared over x squared, and then we're going to reduce that down in a minute. So it's minus 3x squared over 12x squared minus another 3x squared over 12x squared, and then plus 1 over 144x to the 4th. All right, well, let's think here. These are really minus a half, minus, or excuse me, minus a fourth, which is minus a half. So this right here and these two right here will all make plus a half, right? Because you're taking minus a half and then 1. So 1 take away a half is positive 1/2. So I'm going to have 9x to the fourth plus a half, right? Because this number and these two combine together. And then plus 1 over 144x to the fourth. That factors to 3x squared plus 1 over 12x squared. And I can put that back in to the problem. Actually, I'm going to do it in this color. All right, so let's take all of this, well, this piece right here, and we're going to substitute it back in. So that becomes 2 pi integral from 1, sorry, you couldn't see that, to 2, or excuse me, 1 to 2, not to 2 pi, geez Louise. And then it was x cubed plus 1 over 12x. That part hasn't changed. But what did change was everything underneath that square root. So I guess if I wanted to put my arrows to be a bit more precise. I just ruined my whiteout. There we go. I can make it go right back in here. And then that becomes 3x squared plus 1 over 12x squared, all squared. Right? I combined what this was with algebra. Right? Distributed, combined like terms, and then refactored it. Now, if you're thinking what I'm thinking, hopefully you are, that's a square root of a square. So that's going to go away. So it's going to leave me, the surface area is equal to 2 pi integral from 1 to 2 x cubed plus 1 over 12x, like that. And then this is going to go away and just leave me 3x squared plus 1 over 12x squared. Right? Because what's happening is the square root and the squaring are going to undo each other. Like that. All right. Because they're inverse functions, if you want to know, right? Algebra, right? So 2 pi. All right, now I can distribute this. This is, I mean, it's going to be ugly, but I can do it. Again, we don't usually do surface areas by hand like this, but yeah, it's good for us. It builds character. Okay, so if I distribute all of that, I'm going to get 3x to the fifth, because x to the third times x squared is x to the fifth. Let's see, 3x to the fifth plus 1 over 12x. Oh, 1/12 x, I mean, right? Because there's x cubed and there's x squared. And then plus 1/4 x, right? Because 3 over 12 makes 1/4. And then plus 1 over 144 x cubed. That x cubed is in the denominator. And the other ones are not. Oh, dx. I've lost space for my dx. I got a little too broad there. Okay, so then this is 2 pi integral. I can combine like terms in the center there. So from 1 to 2, that'll be 3x to the fifth. And then these two combine to make, well, let's see, that's 1/12, that's 3/12, that's 4/12, which is 1/3. So that's 1/3 x plus 1 over 144. I'm going to rewrite that as x to the -3 back there because I know I'm going to have to integrate this next because I've just combined. So if I'm going to have to integrate it, I might as well write it as a power. All right, so this is equal to, let's finally integrate. Woohoo! Using some calculus. All right, so this will be 3/6 to the 6th, so that's 1/2. So 1/2 x to the 6th plus 1/6 squared, because you add 1 and then multiply by a half, and a third times a half is 1/6. Plus, oh, and it's not plus, it's minus, because we're going to add 1 to the power. It'll be -2. So it'll be minus 1 over 2 times 144 is 288, x to the -2. And we're going to take that from 1 until 2. And I am totally not going to do that by hand. No, 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 no. That is going to be Desmos. Let's go grab Desmos, shall we? Here we are, and we have the curve, and I have the integral calculations, well, two ways. One, I actually just found it by typing it in. I used the f of x was equal to x cubed plus 1 over 12x, and then I dealt with that. I didn't graph it that way because that doesn't have restrictions. So the real curve looks like that, but I'm only looking at a section of it. So I have the graph portion down here, but I'm using f of x for the actual calculation because I don't want to restrict it for the calculation. It won't work right. And then I want to check that my by hand integral work that I was just doing works out. So I put in the by hand integral after I'd already integrated, and then I tell it to find me 2 pi and then k of 2 minus k of 1, and sure enough, it is exactly the same. Hooray. All right, so 201.078 centimeters squared. So let me write that down. So the surface area is 201.078 centimeters squared. Now, that was not actually what was asked for. What they asked us to find was the volume of paint needed to cover the outside of the funnel with a layer of paint that was 0.05 centimeters thick. Volume. So I'm going to take that surface area and I'm going to multiply it. Now I'm going to only do the outside of the funnel. So the volume of paint for the outside of the funnel will be found by taking the surface area and multiplying it by the thickness of the paint that you want. So you take 201.078 centimeters squared. I mean, think about what you're looking at. You've got this funnel, right, that you're building from the curve that you had, right? So if you're going to paint the outside of the funnel, right, so the surface area finds the area of that infinitesimally thin funnel. So you take the surface area and you multiply it by the paint thickness, which in our case was 0.05. And we would have, let's see here. Let me go back to Desmos. 10.054, right there, 10.054 centimeters cubed. Now, that's only if you're painting either the inside or the outside of the funnel, which was asked for. But just for the record, if they wanted you to paint both the inside and the outside, then you'd actually multiply by 0.10 because you do it twice. You do it once for the outside, which is 0.05, and then again for the inside, which is another 0.05. Or if you like, it's 0.05 times A, which is what I called the area I called 2, right? See, I named it A equals, that way I could do it this way. So 0.05 times area times 2, right? Because you have to do both the inside and outside. It wasn't asked for, but it's a good thing to know. All right, so this would be 10.054 centimeters cubed. This is what they actually asked for. And then I think it's a good thing for your notes to note if you want to paint the inside and outside, to paint inside and out, you would take surface area times paint thickness times 2, right? So to be 201.078 times 0.05 times 2, because you're painting both the inside and the outside, which was 20 point, oh, now I can't remember. And again, it wasn't asked for, but for your notes, you'll want to write this down. So 20.108. Because it can make a difference on questions, say for quizzes or worksheets or exams.